Okay, yeah.
Sounds like you got it working.
We did, yeah. We just got it.
Okay, cool.
So it should be working. Awesome.
How have you been? How was your summer? Your elbow
It
all
was,
healed?
yeah, it's been a great summer. Yeah, I just got cleared a couple weeks ago that I can start throwing again.
Okay,
And working out and getting in shape again. So I've been doing that,
cool.
which is fabulous news. Yeah.
Are you back at Chatfield?
Uh-huh. I am, yeah.
So you're taking their geometry course there.
Uh-huh.
You have a
Yeah, geometry.
textbook? Is it this? I think it's the same textbook that I have.
Is it? It might be, yeah.
You have it in front of you?
I don't. Do you want me to go get it real fast?
Yeah, it might be useful to
Okay.
know that we have the same textbook.
Okay, cool. Yeah, I'll be right back.
All right.
All right, cool. Okay, I got it.
My authors are Larson, Boswell, and Stiff.
Yeah, so Larson, Boswell, Canold, and Stiff.
Yeah. Okay, good.
Yeah, and then it's like McDouble or McDougall,
Dougal, I
Royal
found.
Geometry.
And it says
Yeah.
geometry, reasoning, measuring, and applying.
Reasoning. Let's see. Does it say that? It doesn't say that on mine, but
Oh, it
I
does?
think it's the same.
Okay, but I suspect it's a same book,
Yeah, it's
different
like a.
edition, maybe. I might
Yeah,
have an older edition or a newer edition. But that's,
exactly.
that's good. If you end up with problems that are out of the book, then
Uh huh.
that'll save you some time. You won't have to send me pictures.
Exactly. Okay.
But
Awesome.
it's fine if you send me pictures. If the teacher
Okay.
gives you stuff like this.
Yeah, it was just like it's like review for a test that we have
Okay.
coming up coming
I'm a
up
little, I'm a
on
little
Wednesday.
curious as to what did you do differently the second time you sent these images over the first?
I sent them as like small images.
Ah,
So like when I send them in my email, they're like you get like a size option, so it's like small, medium, and large. So the
okay.
first time,
Okay.
yeah,
Small ones,
yeah,
when I blew them up to this size, they were so blurry I couldn't read them. So,
that's weird. Yeah,
so I guess
okay,
always send the larger kind.
yeah. It just like the reason I sent the reason I sent the small like pictures first was because it used like less storage on my phone.
Ah,
But
okay.
but yeah, that's all right.
You
It's
have
all
an
right for.
iPhone?
Yep, the iPhone 5. Yeah,
I've had that problem with other students.
really.
That's a very common mistake is they send them as small images and
Yeah,
resolution doesn't come in clear enough for me to see them
yeah,
once I blow them up.
exactly. Exactly.
So that
Yeah.
must be what's going on. I've never understood it before until you just explained it to me.
Yeah, I like never did that before. Like I sent it to your text, but yeah, I think that's the reason why it was all blurry.
Well, and I should be embarrassed to admit this, but I don't know how to take something that you sent to me as a text and forward it to my email. In other words,
Ah,
for me to get
don't
it
worry
on
about
my computer, I got to get it on my I have to
it.
have
It's hard.
not to my phone, but to my email address.
Oh no, don't worry about it. Yeah,
So,
it's no problem at all.
so yeah,
Yeah,
in the future, just send them to my email, and then there won't be any.
definitely.
So, okay,
Yeah,
so
no
we
problem.
want to review all of this that you've done,
Uh-huh.
and it
Yeah.
looks like 1 through 7.
Yeah, so like we went over it in class today.
Okay.
And like I'm just like I didn't get the same like I get for most of the answers I got them right, but like for a few of them I didn't get right.
Well,
So like
number 4 is not right.
number
What's,
four
what's
isn't.
another name for CB? It's not
Uh,
A. In other words, CA is a different line. Notice.
CA, yeah. So
Uh,
it'd be CB. Would it be CB? No,
B,
because like
BC.
B BC. Okay.
In other words, just reverse. BC is the same as CB.
Okay.
Okay? So instead
Cool.
of that CA right there, put
hmm
BC.
Okay.
Name two pairs of opposite rays, and you have BA and BC.
Uh-huh.
Um, I
Just
think
like B is the
the answer
midpoint.
should be
Hmm.
AC and CA.
AC and CA.
Yeah, in other
Uh,
words, AC is the same ray as
uh-huh.
BA is, but
Okay.
it's opposite. It
Yeah.
goes in the other direction. Whereas AB or BA is not the same ray as BC.
Okay, because
Different.
B is the midpoint between the 2 points.
Right, right.
Okay.
If we're looking for rays that are the same line, only
Uh-huh.
opposite in direction,
Yeah.
then AC would be the same as CA, only opposite in direction.
Okay.
I believe
Cool.
that's right. Some of these I'm not 100% sure of, just
Hmm.
because, I don't know, this is terminology stuff, which is always a little tough.
Okay.
I'm not an expert on the geometry terminology, but let's see. Give another name for EB. What would another name
Okay.
for EB be?
So EB would be,
Not
would it be
EBF. Notice
FBS
that
or BF
EBF is this whole line.
or FB? Okay. So would it be FB?
Well, it would
FB would
be
be one
BE.
or BE?
Yeah.
Okay.
Another name
Just flip
for
them.
EB is, yeah, exactly. If you flip
Okay.
the letters, it's the same line.
Okay.
Okay.
Cool.
Whereas if you
Okay.
add a letter, now you're increasing that line segment.
Okay.
EBF is that in total segment there, whereas EB is just part of it.
Okay. Cool.
Name the intersection of line L and AB, point B. Okay, cool.
Awesome.
Let's go down, look at 8. Find the
And then yeah,
length.
for these. Oh my bad. Go ahead. So for these, like I was confused. Like I don't know how to do these ones.
Okay.
Like 8 and 9. Um,
Well,
like I thought that was right because GM is 2x minus 3. Wouldn't that be
well,
right?
yeah,
Or
but
no?
they want you to solve for x, basically. Hold on,
Okay.
pop up my so I can write.
Okay.
I because of that hash mark right there,
Yeah.
that means that GM
Oh, that's the
is the
midpoint.
same as ML.
Oh, okay.
So what equation can I write?
Uh, 2x minus 3 plus x plus 4.
Well, I can say
Right.
2x minus 3 is equal to x plus 4.
Okay.
Because that's what the hash mark means. The
Yeah.
hash mark means that that line segment right there is the same as this line segment.
Okay.
And once you put it into an algebraic equation like this,
Uh-huh.
I
Then
can
you can
solve.
solve it.
Yeah, now I can solve for x and I can figure out what GM is exactly. Because
Okay.
GM is indeed 2x minus 3, but I need to solve for x. So let's solve this. What algebra do I need to do to solve that equation?
So you would subtract x from both sides.
Okay,
So
so
you
what's
would
the next
get
line?
x minus 3 is equal to 4.
And then what?
And then you would add 3 to both sides. And then so it'd be x is equal to 7.
So
And
now
that's your answer.
GM, yeah, that's
And then,
not the answer because remember
or like
GM is
9.
2x minus 3.
Uh-huh.
So plug in 7 for x and what do you get?
And then plug in 7, so you would get 7 times 6, 14 minus 3, 11, and then
That's what GM is.
so 21. Oh, it'd be 11. Okay.
GM is 11. In other words, GM is just the 2x minus 3 part.
Okay. Gotcha.
All right.
Okay. Cool.
And let's.
Okay, and then so now find TV.
Okay. TV is what? What equation can I write for TV?
12x plus 20.
Okay.
Or would,
So
so 12x plus
TV
20.
equals 12x plus 20.
Uh-huh.
What else is TV equal to according to this?
7x minus 3 and 48.
So 48 I'll put first because it comes
Uh-huh.
first.
Yeah.
Plus 7x minus 3.
Uh-huh.
Okay. Well, TV is equal to TV, right?
Uh-huh.
So
Yeah.
now I can say that is equal to this. And then I'll be able
Oh,
to solve for x. In other words,
okay.
I have 12x plus 20 equals, well, 48 minus 3 is 45, so
Uh-huh.
45 plus 7x.
Mm-hmm.
Now, again, once you get one equation and one unknown, then you can
Mm-hmm.
solve always. If I have two unknowns, I can't solve if I only have one equation. But if I have
Yeah.
only one unknown, I can solve it. So now
Uh-huh.
I got 5x combining the x's equals 25.
And then x equals 5.
And now TV is 12 times 5 plus 20. So
Okay, so that'd be
TV
60
80.
or 80, yeah.
Yeah.
So TV is equal to 80.
So the secret on all of these is to try to come up with an equation that only has one variable.
Okay, that makes sense. Perfect.
Okay.
Okay.
One.
And then 10, 11. So my teacher, like, he doesn't explain, like the concepts, like, at all. Like, he expects us, so he's like, he gives us the homework and then, we're just supposed to do it. Like,
What?
he barely explains each problem. So, like, I'm kind of, like, confused on a few of these.
Okay, well, that's okay.
Okay, cool.
That's good for me, huh?
Uh-huh, yeah,
If he was really good, you wouldn't need me.
exactly. There you go.
So the first point is right there.
Uh-huh,
I can just approximate it. I
yeah.
don't have to draw
Yeah,
a grid or anything. The
yeah.
second point is right there.
Okay. Yeah, 10,
Now,
-1.
the midpoint is always halfway between the x coordinates and halfway between the y coordinates.
Okay.
Okay? Now,
Mm-hmm.
how do we figure out halfway? Well, there's a couple of ways. Let's take a number line,
Uh-huh.
put 0 on it.
Yeah.
My x coordinate is -6 here. My x
Uh-huh.
coordinate over here is 10. How do I figure out what's halfway between those two?
You find like what's halfway between -6 and 10?
Well,
Or do you
do
just
it, do it on the
subtract?
number. There's an algebraic way to do it. The algebraic way to do it is to add the two numbers together and divide by 2.
Oh, okay. So it'd be 4 divided by 2, so it'd be 2. The midpoint would be 2.
So the x
Okay.
coordinate of the midpoint is 2.
Okay.
What's the y coordinate? Same thing. Add the two numbers together, divide by 2.
It'd be 2. Right.
It'll be 3. 7 and minus
Well,
1.
oh, I didn't see. Yeah, okay. Yeah,
Add
yeah, yeah.
6. Divide 6 by
Divided by
2, you
2.
get 3.
Okay.
So, however you want to do it, you can do it. In other words,
Uh-huh.
if this was 6 and 10, it's easy enough to see the midpoint would be 8.
Yeah.
But
Okay.
since one of them's a negative number and the other one's a positive number, when we go
Mm-hmm.
down here, I can see that 2 is the midpoint between those two because
Mm-hmm.
2 is 8 to there and it's 8 to there.
Okay, cool.
But you
And then,
get that algebraically by adding them together and then dividing by 2.
okay, so you add them together.
Yeah,
Okay.
but sometimes they may give you the problem differently.
Uh-huh.
In other words,
Like a negative.
I'm sure that they're going to give us a problem like this, where they give you one endpoint
Uh-huh.
and they give you the midpoint.
Oh, and then you have to find
You
the
have to
other.
figure that one.
points, yeah.
Well, this isn't quite as easy, but
Mm-hmm.
what you have to do is figure out on the x-coordinate, how far did I have to go? I went 8 units to the right to get
Uh-huh.
minus 6 to 2.
Okay. Yeah.
Well, that means you have to keep going 8 more units to the right. Well, so I add 8 to 2 to come up with 10.
Mm-hmm.
Same thing with going from 7 to 3.
Okay.
How do I get from 7 to 3? I go down by 4 units.
Okay, because you just subtract those two.
Yeah, well,
Yeah.
yeah.
Or,
Just understand what you're doing. In other words, I hate to put it in terms of just adding or subtracting.
mm-hmm.
It's more of how many do you go and which direction.
Okay.
Well,
Gotcha.
I got to go down 4, right? To get from 7
Uh-huh.
to 3, I got to go down 4.
Uh-huh.
So to find
Yeah.
this endpoint, keep going down by another 4. And that gets me
Uh-huh.
minus 1.
Okay. Cool.
And that's the way to think about endpoints and midpoints. And they will,
Okay, cool.
all of your problems are going to be combinations. They'll either give you the 2 endpoints and want you to calculate the midpoint, or they'll give you one endpoint and the midpoint and want you to calculate the other endpoint.
Okay.
Let me just give you a quick example.
Okay.
We'll go from minus 2 comma 8,
Mm-hmm.
and that's 1 point.
Mm-hmm.
And I'll give you a midpoint of 5 comma 2.
Mm-hmm.
So what is this endpoint over here?
So that's -2, correct?
Right?
Up there? Okay, so it'd be 3, 6.
Hold on. How far do you have to go to get from -2 to 5?
Oh,
In other words, take each variable by itself.
okay, so you have to go 7.
You have to go 7 to the right.
Yeah, 7 to
And
the
the
right.
direction
So
is important. In other words, it's not just 7. It's 7 to the right.
yeah,
So,
because you're going from a negative to a positive.
well, I'm going from this point in that direction on the x-axis.
Okay.
And I'm going 7 units. So, what's
Okay.
the x-coordinate of this endpoint?
So the coordinate would be 7.
7 plus 5.
7 plus, oh, so it'd be 13.
12.
Or 12, excuse me.
Okay.
Yeah.
And now you can
Okay.
see that 5 is indeed halfway between -2 and 12.
Uh-huh.
You add -2 to 12, you get 10. Divide by 2, you get 5.
Okay.
What's the y-coordinate?
And now the y-coordinate would be, so 6 plus 2
Hold on.
would be
6. 6 which way? Up or down?
6 to the left,
No,
because you're going down.
Hold on. When you're dealing with the x-coordinate, you're either going left or right.
Oh, and the y-coordinate
With
is
the
up and down.
y-coordinate, you're either going up or down.
Okay. So for this, you'd be going down.
Down by 6. What's
Down
6
by
lower
6.
than 2?
6 lower than 2 would be 4.
-4.
-4, yeah, -4.
In other words, that basically becomes the answer to that. It's 2 minus 6. Because I'm going down, I'm going to subtract 6. If I had to go up, I would be adding 6.
Okay.
I'm going to subtract 6, so I'm going to do 2 minus 6 to get -4.
Okay.
And then again, once you have the endpoint, you can check your answer by taking 8, adding it to -4, which gives you +4, dividing by 2, here's your midpoint. So this midpoint fits our picture now. In other words, that whole picture is right.
Okay.
Okay?
Okay. Cool.
Let's do 11. Find the coordinates of the other endpoint. Okay. I hadn't looked at 11 yet, but 11 is what I just did.
Yeah.
In other words, let's let's draw it. If there's ever any confusion, it's always a good idea to just draw. And like
Yeah,
I
for
said,
sure.
you don't need to be precise. You don't need to put a grid on this. Take that much time.
Uh-huh.
That's point Q.
Okay.
The midpoint is at -6, -4. Well, there's about -6. -4 we'll make right there. So
Okay.
that's the midpoint, and that's -6, -4. So there's some point over there
Mm-hmm.
that's the other end point.
Yeah.
That
Okay.
is R.
Yeah.
Now, let's take the x coordinates only.
Okay.
To get from Q, which has an x coordinate of 2,
Mm-hmm.
to the midpoint, what do we have to do?
You have to go down.
Not down. Remember, on the x coordinates, you're either going left or right only.
Okay, so you would go left -4
How
points.
far do you have to go? Let's take a number line here. It's
Okay.
frequently easier to understand if you're looking at a number line.
Mm-hmm.
How far do I have to go to get from 2 to -6?
You have to go. You have to go 8 points to the left.
Okay. So let's keep going another 8 points to the left.
Which would take us to 16.
-14.
Or -14. Okay.
And again, you can do it algebraically, but it's actually easier to get confused when you do it algebraically.
Okay.
The key is to notice that that's 8 units.
Mm-hmm.
There to there.
Mm-hmm.
Well,
Yeah.
that's another 8 units from there to there.
Mm-hmm.
And that's all you have to care about. Whether
Okay.
it's -6, -8 gives you -14, that's the algebraic way, but
Yeah.
it's tough to know whether you subtract or add. Okay? All right. Now,
Okay.
so we've done the x coordinate. It's -14.
Uh-huh.
Now let's do the y coordinate. So the x coordinate of point R is -14. Well, to get from Q to M on the y axis, what do I have to do?
You have to go down 1.
Good. So what's the y coordinate on R?
That would be -7, right?
No, go down another one.
So, so just be -5.
Exactly.
Okay.
Now you see,
Okay.
you understand why?
Yeah.
In other words, to get from -3 to -4, I had to go down 1.
Uh-huh.
So I have to go down the same amount. And I have
Yeah.
to go in the same direction. In other words, I have to go down, not up.
Yeah.
And when you go down 1 from -4, again on a number line, if this is -4, and you're going down 1 unit, you go to -5.
Okay. Okay. So it'd be.
I suppose on the y coordinate, it's actually easier to view the number line this way.
It is, because you're either going up or down.
And that's -4, so if I go down another 1, it's down to -5. In other words, here was -3.
Okay.
You go down 1 unit to get to -4. Got to go in the same direction, the same amount.
Yeah.
That puts me at -5.
Okay, cool. Perfect.
Okay.
Okay. Awesome.
Vertical angles are, if I take 2 straight lines and cross them, I have 1 and 2 are vertical angles.
Yeah.
And 3 and 4 are vertical angles.
Okay.
Vertical angles are always equal.
Okay.
Linear angles would be 1 and 3.
Uh-huh.
Or
Yeah.
4 and 2.
Okay.
or 3 and 2, or 1 and 4. In other
Okay.
words, linear angles always add to 180. They're always supplementary.
Yeah, that makes
Whereas
sense.
vertical angles always equal one another.
Mhm.
Okay? So if I look at 1 and 3 here,
Mhm.
those aren't quite linear angles. They're certainly not vertical angles. They don't fit
So
the
they're neither.
cross, so they're neither. Yeah.
Okay. Yeah. Okay.
2 and 3 are neither
Uh-huh.
for the same reason.
Yeah.
They're not
4
equal
and
to one
5.
another and they don't add to 180.
Okay. 4 and
4 and
5.
5 are what? Linear? Okay,
They're
that's
yeah,
correct.
they're
5
uh-huh.
and 8 are vertical, meaning they're equal.
Yep.
And 4 and 9 are vertical.
Are vertical cuz they intersect
Well,
at
because they fit this picture over here.
yeah.
In other
Mhm.
words, notice that if I eliminate everything from the picture, but this part right here, I've got two vertical angles that are crossing.
Yeah.
So 4 and 9 are vertical, 8 and 5 are vertical.
Okay.
And there's no
Cool.
other vertical angles in this thing.
Mhm.
Those are the only set of vertical angles.
Yeah. Okay.
But 6 and 7 would be linear.
Uh-huh. Yeah.
And 1, 2, and 3 could perhaps be called linear.
Okay.
Not a linear pair of angles, but a linear tri of angles.
Okay.
Right.
Yeah.
Okay,
Okay.
let's see. Tell whether it's convex or concave. Okay, the whole problem on these is, can I draw a line
Mhm.
starting from one corner of this object to any other place and have that
Yeah.
line go outside of the figure?
Uh-huh.
You can't.
No, you can't. So would it
Not
be
on that first one.
so it's not a polygon?
No, it is a polygon,
Or
but
it is polygon like
the question is whether it's convex or concave.
uh-huh.
In other words, if I draw a line from there to there, I'm inside the polygon the whole way.
Uh-huh. Yeah.
Where, so that I believe is convex.
Okay. Okay, yeah.
Whereas this figure here,
Mhm. It's not a polygon because it has 7
well, it's a
sides.
polygon.
It is?
Yeah. Its question is
Uh,
whether it's convex or concave. Notice the question. Tell
okay.
whether the figure is a polygon and whether it's convex or concave. Well, a
Okay.
polygon is merely any figure that's surrounded by lines. In other words, if
Okay.
I have that, that's not a polygon.
No.
But as long as I have something like that,
Uh-huh.
that's a polygon. But notice that the polygon that I've drawn is, I can take a point right there, and if I connect it to that point right there, I go outside of the polygon.
Yeah, so it'd be concave.
That's concave.
Yeah. Okay.
Okay, so they're both polygons,
Yeah.
but
Okay.
this is, I hope you have it right. I may have it backwards. I'm not, I
Mhm.
think this is convex and this is concave.
Yeah,
They're
that's what the
opposite
teacher
one
said.
another for sure.
Uh-huh.
Okay,
Yeah.
but I'm not 1,000% sure.
Mhm.
That's a horrible expression to use, isn't it? I'm not 100% sure which is convex and which is concave. I don't
Uh-huh.
run into it often enough.
Yeah.
This one is also a polygon. Well,
Mhm.
yeah, I'm not sure if polygons can have curved lines in them.
Yeah. Don't they have to be straight?
Well,
Like,
if they do, then that's not a polygon.
yeah.
I'm not sure
Yeah.
about the terminology for polygon. Let me see if the book has it
Sure.
here. I'm looking at your book, and I didn't actually see this part on here.
Mm-hmm.
I believe polygons have to be straight edges,
Mm-hmm.
which makes this not a polygon.
Okay.
If it were a polygon, it would have the same concavity as this one over here, because I can take a point there and I have to go outside to connect it to a point there.
Yeah, so it'd be concave because, yeah,
Yeah,
because like
be
two
concave.
sides. Like,
Assuming this is concave, then this is also concave.
okay.
And assuming these are both concave, then this is convex. But
Okay.
I'm not even sure that you can talk about a non-polygon as being concave or convex. In other words, if it's not a polygon, and this I don't think is,
Uh-huh.
then it's neither, I believe.
Okay.
Because according
Yeah.
to the question, well, tell us whether it's a polygon, and if it is it convex or concave? If it's
Mm-hmm.
not a polygon, I don't think you can classify it as either. I'm not
Okay.
100% sure about that,
Okay.
but
Gotcha.
that's just terminology.
Okay.
Okay, let's go to
Cool.
the next page.
Okay. Well, my voice is cracked.
Let's see. Do I have these right? Yeah. Is this the next page?
Yeah, it is.
Cool.
Yeah.
Yeah, and all of these problems are going to be basically writing an equation and solving it.
Okay.
Okay.
And then I think I got. Yeah, I know I got the.
20. Let me look at what you've got here.
Yeah, I know I got that one wrong.
Okay. They give us the angle from here to here. In other words, NRQ is this big angle.
Uh-huh.
Well, they're telling us that that's 78 degrees.
Yeah, I accidentally like equaled it to 90 degrees instead.
What is it equal to according to the algebra?
78 is equal to 8x plus 7 plus 4x minus 1.
Exactly. In other words, it's equal to the sum of these two angles.
Mm-hmm.
So I
And then
can
you
say
plug in
8x. Well, now we have one equation and
Uh-huh.
one unknown.
Yeah.
Whenever you have one equation and only one unknown, you can solve it.
Uh-huh.
Whereas this now becomes 78 equals 12x plus 6. Subtract 6 from both sides.
It's 12x, then x is equal to 6. Yeah.
Okay, and then find angle PRQ. We're going to plug in 6 to this part here.
So that'd be 24 minus 1, which is equal to 23, so x would equal to 23.
Well, no. The angle is equal to 23. X was equal to 6.
Yeah. And
But
then
x isn't the angle. X is just a variable.
Uh-huh.
So we need to plug in what we found for that variable into this angle, which is 4x minus 1.
Yeah.
Okay.
Okay. Cool. And then it's like it's the same one for.
It's similar.
They're similar. It's
The
not
difference
the same.
here is that they're telling us that BD bisects the big angle.
Uh-huh.
Well, what does that mean? That means what about this angle and this angle?
That they are the endpoints, like the end segments.
Well, what are they? What does it mean for BD to bisect ABC?
It means it's like cutting it in half.
Okay, which makes this angle equal to this angle.
To the yeah.
So the equation is what?
So the it would be 5x plus 2 plus or is equal to 7x minus 6.
Now solve that.
So we could subtract 5 from both sides. So we'd get 2 is equal to 2x minus 6. Then you add 6 to both sides, and then x would equal to 4.
But again, they want the full, complete angle.
Yeah, so you would plug in 4 to both of the x's.
Okay, and then add those, well, or double it. In other words, when we plug in 4 to that one, we get 22.
Yeah.
And we know that ABC is twice this angle, so it has to be 44.
Uh-huh. 44, yeah.
Okay.
Okay. and then it's like it's the same for.
Similar. It's not quite the same, but it's a question of writing an equation that you're going to be able to solve.
Yeah.
So what equation can I write between these two? I got this angle here, and I got this angle here.
So for A,
What's
B,
true
and
about
C. So A, B, and C is obtuse, and then C, B, and D is acute.
Okay.
So for A, B, and C, we could do 8x plus 9 is equal to 180.
Hold on.
And then
Hold on. Yeah. What are these two angles called? Are they vertical or a linear pair?
They're not vertical.
Huh?
They're neither.
They're a linear pair. Whenever you have a straight line,
they're linear.
And you have another line that intersects that, you create two angles, 1 and 2.
Yeah.
They're not only a linear pair, but they're always add to 180.
Okay. Gotcha.
So the way to solve this is to take this angle, add this angle, and let it equal 180.
Okay.
So what's my equation going to be?
So it would be 8x plus 9 is equal to 180.
Hold on. No.
Or 8x plus 9 plus 6x plus 17 is equal to 180.
That's what's equal to 180.
Yeah. Okay.
And then again, one equation, one unknown. We don't need to go through the algebra of it. I'm sure you know how to do that. Let's
for sure.
Get as far as we can here trying to set up the equations. Because that's the whole problem on all of these.
Yeah, exactly.
Setting up the equation.
Exactly.
Okay, hold on for a moment. Let me close my door. All right. So here I have two lines that are not necessarily perpendicular, but what do I know about that? If I had angles 1, 2, 3, and 4, I would know that 1 is equal to 4, 2 is equal to 3, and 1 plus 2 is equal to 180. Also, 3 plus 4 is equal to 180.
Yeah.
So using that strategy, let's come up with some equations. We have two variables here. So we're going to need to solve for one variable first.
Okay. Yeah, so let's...
One equation can I write that only has one variable in it?
14x plus 4 plus 16x minus 4 is equal to 180.
That allows you to solve for x.
Yeah, and then, like for the other variable, we do 4y minus 8 is equal to 180 as well.
Hold on. Notice that had I wrote the wrong first equation, in other words, I also know that 14x plus 4 is equal to 4y minus 8. That is a true statement, right? Because they're vertical angles. The problem is that has two variables in it, and I can't solve it.
Yeah,
So I have to solve for x first. And I solve for x using that. In other words, using the relationship between a linear pair of angles.
Yeah.
Okay, so if I solve the first one first, which I can solve, I get 30x equals 180. So x is equal to 6. Well, now I know that 14x plus 4 is equal to 4y minus 8, right?
Yeah.
So 14 times x, which is 6, plus 4 equals 4y minus 8. Now, again, I have one equation and only one variable. So
okay, yeah, that makes sense.
Solve for y.
Okay, so
you have found both x and y.
Yeah.
So this relationship between linear angles and vertical angles is really key. In other words, because you have two pairs here. We have vertical angles there, and we have linear angles there. And we also have linear angles here.
Uh-huh.
But unless I take this specific pair of linear angles, I can't solve for anything.
Mm-hmm. Yeah.
Because this plus this equals 180 allows me to solve for x.
Mm-hmm.
Once I've
Yeah.
solved for x, now I have three different ways I can solve for y. I can say
Yeah.
that equals this, or I can say this plus that equals 180. I
Mm-hmm.
have all kinds of ways to go.
Okay.
Okay?
Gotcha.
So
Okay.
this concept of linear angles and vertical angles is very important.
Uh-huh.
So
Okay.
24,
Mm-hmm.
A and B are supplementary, find them. Well, here's A,
Uh-huh.
here's B. The fact that they're supplementary means what?
That they add up to 180 degrees.
So what equation can I write?
So you could do minus 4x plus 40 plus x plus 50 is equal to 180.
Now notice that I use parentheses.
Yeah, I just like to split them up.
I didn't need to.
Mm-hmm.
I
It
did
just
it
kind of
only
makes.
for clarification.
Okay.
This is angle A, this is angle B.
Mm-hmm.
Obviously angle A plus angle B, since they're
Uh-huh.
supplementary, it's equal to 180. Now the next step is to remove the parentheses
Yeah.
and then solve. Well, in
Okay.
this case, I can just remove the parentheses without changing anything. It has the
Uh-huh.
same meaning as it did with the parentheses.
Okay.
If this was a minus sign, that wouldn't be true.
Mm-hmm.
But because it's
Yeah.
a plus sign, it is true. So now we just combine everything. What do I get?
So you would get minus 3x plus 90 is equal to 180.
Okay, keep going.
And then you subtract 90 from both sides. So you get 3x minus 3x is equal to 90 divided by 3. X is equal to 30, negative 30.
Can x be equal to a negative number?
No,
Yes.
it can.
X can. An angle cannot, at least not at this stage of geometry.
Okay.
Once you get to trigonometry, then
Mm-hmm.
positive angles go counterclockwise, negative angles go clockwise. But
Okay.
at this point, all angles are positive. So
Okay.
notice that if I plug in minus 30 for x,
Mm-hmm.
well, that's minus 30 times minus 4 becomes 120 plus 40, that becomes
Which
angle A
is
is
180.
160. So
160. Okay.
angle A is 160, and they want you to solve for angle A.
Mm-hmm.
Angle B
Yeah.
is minus 30 plus 50, so angle B must be 20.
Mm-hmm.
So
And then you
notice
add
that
this up and that they equal
both
180.
angles ended up being positive,
Uh-huh.
even though I had a negative x.
Uh-huh. Yeah.
So you can have the variable be negative, but you cannot have the angle be negative.
Okay.
Not for
Yeah.
these problems.
Yeah. Okay.
And
Cool.
this is the second time I've seen this problem. I have some other geometry students that have received this same set of problems. Because
Oh, cool.
I remember doing this exact one where x came out to be negative 30.
Oh, cool. Was it? Do I know any of them?
Ah,
Like, do they go to Chatfield?
I
Yeah.
don't remember who my geometry student is at Chatfield, but I think I have two. Um,
Okay. Uh-huh.
Cole's one of them.
Yeah, Cole White. Yeah.
Cole, incidentally, is doing fabulous with math.
That's awesome.
It is. I can't believe how much he's changed. By
That's
the
good.
time we were done with algebra
Uh-huh.
last year, he would have
Yeah.
gotten an A in algebra if he took algebra this year.
Wow. That's
And
awesome.
how he'll do in geometry, I don't know, but he and I worked on geometry all summer. So he
Oh, wow.
and I have already put in quite a bit of work to geometry, but
Wow.
not on this stuff here. But I think he's doing okay. And then I have
Uh-huh.
somebody else going to Chatfield that's taken geometry also, and that was
Oh,
actually
cool.
the person that I ran into this problem with, and I can't remember who that is.
Was it a he or she?
Ah, I don't know.
Yeah.
Let me think for a second if I can think
Mhm.
of what her name or his name might be.
Yeah.
I can't. I'd have to look back through my calendar at all my students and try to figure out who it was that gave me this problem. But
No problem.
if I can
No
think
problem.
of it, I'll let you know later.
Yeah, no problem. Yeah, but cool.
So in general, I don't tend to like to tell names of other students just because it might be, a student may not want, you may not want me to be telling other people that I'm tutoring Dylan's staff.
Yeah, I totally understand what you mean. Yeah.
So that's the only reason
Uh-huh.
I'm reluctant.
Oh
In
yeah.
this particular case, I can't remember the name anyway, but
No, it's okay.
it was really
Yeah, don't
funny.
worry.
It was really funny with Cole. I mean, that was
Uh-huh.
hilarious because I told you it's a Chatfield student that I couldn't think of his name, and I thought it might be Cole, and you said Cole White, and
Yeah.
yeah, it was that.
Yeah, it was him.
That was really,
Awesome.
and that helped me actually because I didn't have to end up asking him what his name was,
There you go.
which is really
Awesome.
embarrassing when you've been working with somebody for like 5 times and you don't know their name. I,
Don't worry. I mean, like, when I come back to school, like, I don't, like, remember half of the kids I know,
yeah.
their names. Like,
Well,
they'd be like, hey, Dylan. I'd be like, hey.
yeah,
Like,
yeah, I know.
got your name for a
Kind of
sec,
like
you
that
know?
myself, but
Yeah,
usually with students, I'm pretty good. But if
that's good.
I miss
Yeah.
it on the first session that I meet them, then the way
Mhm.
I usually get it is I look at the homework they give me the second session, and their name is written across the top. But in
There
this
we go.
case with Cole, he never did that. He never gave me
Uh,
anything that had his name on it. So I was just kind of guessing that it was Cole.
it's like wondering what his name is.
Yeah,
Yeah.
but then when you verified it that it was Cole White, then I was
Hmm.
sure because I knew his last name. I knew his mother's
Uh-huh.
name.
Yeah. Hmm.
So anyway,
Yeah. Uh-huh.
two angles form a linear pair. What does that mean?
So, two, uh, they add up to 180 degrees.
Okay. What
Mhm.
should we call the first angle?
Which one are we on? 26?
Yeah.
Um, we could call it,
X.
I don't know, just X.
Just X.
Okay.
And label it. That is the first angle.
Okay.
Okay?
Okay.
The measurement of one angle is 8 times the measurement of the other angle. So what's my other angle?
So 8 times, so 64.
No, 8x.
Just 8x. Oh, because, yeah.
That means that this angle is 8 times this angle.
8 times that. Okay. Yeah.
Okay?
So,
Now, I
okay.
did have to introduce a variable, but that's
Uh-huh.
okay. Whenever you have to introduce a variable, just always call it x.
Okay.
I don't have to introduce two variables. I could have called x the first angle and y the second angle,
Uh-huh.
but it's sometimes better if you don't introduce a second variable if you don't have to.
Yeah. Hmm.
And in this case, they're telling me one angle is 8 times the measurement of the other. So if I'm going to let x equal the 1, I'm just going to let 8x equal the other.
Okay.
Now,
Yeah.
because they form a linear pair, what equation can I write?
So you could do 8x, plus x is equal to 180 degrees.
So that's 9x equals
9x is equal to
180.
180.
So
And then
one
that'd be,
angle is 20.
uh-huh.
The other is 8 times 20,
Yeah.
100.
So 160.
So those are the two angles. They are supplementary.
Okay.
In other words, they add to 180 and they work.
Yeah.
In other words, when you come up with an answer, it's a good idea to just check it.
Uh-huh.
Make sure that my two angles that I came up with
Uh-huh.
indeed are supplementary.
Yeah.
They are. One is 20, the other is 160. The other thing I'm going to check is this one 8 times this one? Yes, it is.
Uh-huh.
So it fits both criteria.
Okay. Cool. Perfect. Alright, so 27.
Heptagon is what?
A heptagon is
How many sides?
heptagon 11 sides, right?
7, I believe.
7 sides is a 7.
Yeah. Hexagon is 6.
Uh-huh.
Pentagon is 5.
Uh-huh.
Heptagon is 7.
Is 7.
Octagon is 8.
8. Nonagon, right?
Nonagon is 9.
9, then decagon is 10.
Decagon is 10. After that, I don't know.
Then I think 9 is a nenagon, actually. Or 11.
Not sure. I'm not even sure. I'm
Yeah.
pretty sure that nonagon is 9. But
Yeah.
that's not really the important part of geometry, if you want my honest opinion. Remembering what the names of these things are.
Yeah, it's not really important.
Is that they could have said 2 sides of a regular 7-sided polygon.
Uh-huh.
And you could still solve the problem.
Uh-huh.
Okay? So, regular means 7 equal sides, 7 equal angles. I don't even know how to draw it. 1, 2, 3, 4, 5, 6, 7.
There we go.
Close as I can come.
That's all right.
And the lengths in meters of 2 sides can be represented by, that side would be minus 32. All 7 sides are the same. So I'll let this side be 6x minus 7. Find the length of a side of the heptagon and its perimeter. Well, what's the first equation I can state?
We could do, so 11x minus 32 plus 6x minus 7 is equal to 180.
No, we don't know that.
Or is equal to, no, we don't know that. Yeah.
These are just 2 sides. They haven't told us all 7 sides yet.
No.
But what do we know about regular polygons?
That all sides are like equal.
Okay. So let's use that information to write an equation.
Okay, so we could do 11x minus 32 times 7?
No.
Or is equals... Oh, 6x minus 7.
You see why?
Uh-huh.
Because they're 2 different sides of a regular heptagon, but because it's a regular heptagon, they have to be the same.
Uh-huh.
So we easily can say that this side is equal to this side.
Okay.
Well, that's going to allow us to solve for x. Notice that 5x equals 25, which means x equals 5.
Yeah.
And now find the length of one side.
So we could just plug in x.
Okay.
So 11x times, so 11 times 5.
Which is the easier one to plug into?
Probably 6x minus 7.
Always plug into the easier one.
Yeah. So it'd be 30 minus 7, which is 23.
So that's the length of one side. What's the perimeter equal to?
23 times 7, so...
That's it.
Yeah. X is equal to 7. Yeah.
In other words, 23 is the length of one side, and 161 is the length of all 7 sides.
Okay, cool.
Okay? The key, once again, on all of these is figuring out what equation you can write that allows you to solve for the variable.
Okay. Gotcha.
And that's all about definition. In other words, being able to write this equation comes from knowing that every side equals every other side.
Okay.
And they've given us 2 sides. So I can say that equals that. And once I say that, I can solve.
Okay, cool.
Okay. Using proper... Boy, I might have trouble on this one. Name the object using proper geometric notation using letters and symbols.
Oh,
Well, A. What is A?
just my. That'd be like I'm
Okay.
confused on these as
Well,
well.
that's a line, first of all, as opposed to a line segment.
Yeah, yeah,
So
because it's not bisected
it's the line MY.
Uh-huh.
If
Yeah.
you were talking about, if they didn't have these arrows on the end of them,
Uh-huh.
and we were talking about just MY, then that would be a line segment, MY.
Yeah, because
And
it
that would
just stops.
just be the distance from there to there.
Okay,
But
because it just stops.
yeah, but when I say line MY, it means it goes to infinity on both directions.
Hmm.
So I believe the answer to this is line MY.
Just the line, yeah.
And maybe that means this arrow needs to have both directions
sides.
on it.
Yeah.
In other words, I would put a left arrow at the top of that line also.
Uh-huh.
That would mean a line if it has arrows in both ways.
Yeah, same as like letter B too.
Well, let's look at B. Let's see.
BCB.
That's an angle.
Yeah.
So it would be,
Just no line.
well,
Right.
here, how do we write angle here? Just a second.
You're good.
I would describe this as being angle CAB, or angle what? What's another way to do it?
Angle BAC.
Right. But it is not ACB.
No.
Okay.
Because A's like, it doesn't say that, but like,
A is in the middle. In other words, when you're defining an angle, you have to start from the outside, then go to the vertex, and then go to that outside.
Uh-huh.
Okay.
Yeah.
So A has to be the middle letter, whether I call it CAB or BAC.
Yeah.
All right.
Okay.
And shall we finish these three and then
Sure.
be
And then we can call it good.
Yeah.
Okay.
May I?
So angle AL would just be AL with like an arrow pointing to the left, not the right.
Correct. And in fact,
then,
I might make it LA.
Oh, because it's going to the left.
Yeah, I'm not positive about that. I could probably call it that.
Okay.
And I don't know that it matters whether it's going left or right. The fact is that it goes on, but only in that direction. It doesn't go to the right.
Mm-hmm.
But I wouldn't want to call it that, because that would connotate something like that.
Uh-huh.
If I called it AL with the arrow going to the right, I would be talking about something like that.
Mm-hmm.
Okay,
Yeah.
and this is more LA continuing on. In other words, I don't think you want to write it like this. I don't believe that's correct, but it might be. I'm not 100% sure. You might want to check your book or note or something on these. I know you're going to have problems with this because I just had so many geometry students, but I get very, very few that do the first couple of weeks. In other words, all the geometry students I get, I usually don't get until October, where they're a month in.
Yeah,
so,
and I'm in his honors class, so like he's like doing it at a faster pace.
Well, it's not that so much. It's that I'm not super up on notation or definition.
Yeah.
E, well, let's do C first of all.
Sure.
C is just a line segment, or D rather, is what I meant.
Yeah, I know you're good.
So a line segment is just like that with no arrow.
Yeah, because it just stops.
Right. Or I could
Yeah.
do like that. Okay.
Uh-huh. Hmm. Okay.
And finally, that's not a line, that's a polygon.
No, yeah.
Now, the geometric notation for that, I'm not sure what it is, but it, uh, P, Q, M, N, O. The important thing is the letters go in sequence.
Uh-huh.
You could also call it P, O, N, M, Q.
Uh-huh.
And I guess you would just say polygon. And we don't even know it's a polygon. It's
No.
yes, we know it's a polygon. We just don't know it's a regular polygon. So
Yeah.
I guess the way I would describe this is this way.
Uh-huh.
And I don't think you need anything else. You
Yeah, that
don't
looks
need
great.
the last P. That's supposed to be a Q,
Uh-huh.
or rather an O.
Yeah.
So that would be my answer. But
Okay.
I'm not sure if there's anything that belongs on top of that or not, to be honest.
Yeah.
I don't think so. I think this is the
I don't
proper
think
answer.
so.
The one thing that wouldn't be correct would be to call this thing P, M, Q, O, N. In other words,
Yeah.
that would be out of sequence.
Uh-huh.
It doesn't matter
Yeah.
which letter you start with. I could
Hmm.
call it Q, M, N, O, P.
Uh-huh. Yeah.
But it's polygon Q, M, N, O, P.
Okay.
Not a
Gotcha.
line. These things either mean lines or line segments.
Uh-huh.
Put arrows on top like that, I think.
Uh-huh.
Okay?
All right.
All right.
Awesome. Well, thank you.
Have a good week, and I will
All
talk to
right.
you next time.
You too. Sounds good.
All right, Dylan.
All right. Take care.